Hello students, we are back with a chapter aldehyde, ketones and carboxylic acid. Now student, in this module we are going to discuss the method of preparation, in which the first one we are doing is oxidation of an alcohol. Now student, when you talk about oxidation of an alcohol, the term comes as oxidation. Now what is oxidation? It simply means nothing but addition of oxygen or removal of hydrogen. Now, for adding an oxygen, we normally use an oxidizing agent. Now, oxidizing agents are several we have. The first one, it's nothing but acidified potassium dichromate. The second one, if you see, it's acidified or alkaline KMnO4. And the third one, it's nothing but chromium trioxide. But out of these three, the one which we regularly use in our syllabus is nothing but the first one, acidified potassium dichromate. Now, how this acidified potassium dichromate gives us a nascent oxygen? Let's see that. So here I have got nothing but a potassium dichromate reacting with sulfuric acid. Now what happens over here, if you see, in this particular process, we get three nascent oxygen out as a byproduct, which is the main reagent or oxidizing agent for us. Now, out of the 7 oxygen you can see, 3 of them have come out. So remaining 4 will get combined with H2 to form 4 water molecule. So I have balanced it. Now what thing is remaining? 2 metals and 1 sulfate. So potassium will get joined with sulfate to form potassium sulfate, and chromium will join to sulfate to form chromium sulfate, and hence in this reaction goes. But what is the main requirement for us? It's a nascent oxygen. There's another way also by which we can do it. It's called as catalytic dehydrogenation. Let's start with the first one by using oxidizing agent. So here first is oxidation of primary alcohol. So student, here I have got an primary alcohol. Now when I am treating this with an oxidizing agent, potassium dichromate with sulfuric acid, what do I get? I get nascent oxygen. Now what will happen to this nascent oxygen? It will try to remove 2 hydrogens. From where it will try to remove? Oh yes, one from hydroxy group and one from alpha carbon. And hence those 2 H and 1 oxygen will get lost outside as water molecule. So what is left? You have got C single bond O, which will now become as C double bond O. And hence you have got a compound called as aldehyde. But aldehydes gets easily oxidized further to an carboxylic acid. Now student, if we want to stop or prevent a reaction at an aldehyde stage, we can do it very easily. But how to prevent our reaction or how to prevent further oxidation? We can do it easily by using a mild oxidizing agent. And which mild oxidizing agent will be using, student? There are 2. One is we can use PCC or we can use PDC. Now by using this PCC and PDC, suppose on the arrow, what will happen? Further oxidation will be not observed. That means I'll get aldehyde as my main product. Now student, you must be thinking, what is PCC and PDC? So PCC stands for pyridinium chlorochromate, and PDC, if you see, it stands for pyridinium dichromate. Not only student, one more point, that this PCC and PDC, they do not attack carbon-carbon double bond. Let's see some example to understand this reaction. So I have got over here 3 carbon atom alcohol. It's a propane 1-ol. Now when this compound has been treated with PCC or PDC, what will happen? Those 2 hydrogen and 1 oxygen will get removed out as water molecule, and you will get nothing but change in functional group as aldehyde. So the compound will be 3 carbon atom aldehyde propanol. So the shortcut involved over here in this reaction is, I have taken a primary alcohol CH2OH, will get changed to CHO as an aldehyde. So this is a shortcut. Let's apply the shortcut properly. So here there's one question for you, that what is the action of PCC on benzyl alcohol? So student, here there is a benzyl alcohol. Now if you see, do you identify there is a CH2OH group? Yes, it's a primary alcohol. Now what? Use PCC for oxidation. What will happen? That a nascent oxygen will remove 2 hydrogen and O. What you'll have? You'll get an aldehyde, or use a shortcut over there. CH2OH group will get converted to CHO group. That means what will happen in this? You have got an aldehyde. The name of this compound is benzaldehyde. Is it correct, student? Now, let's go for the second example, that is second case of secondary alcohol. So here I have got a secondary alcohol. Again, in the same way, I'll be using potassium dichromate. I've got nascent oxygen. What does nascent oxygen will do? Again, it will try to remove both these hydrogens, one from hydroxy and one from alpha carbon. Water molecule is out. Now what? You have got a ketone as a compound. But now remember one thing, student, ketone cannot be further oxidized, so we don't have any fear of using oxidizing agent. Either you can go for potassium dichromate or you can go for PCC as usual what we have used. So here I have got 3 carbon atom alcohol, propane to all. Now when you use it, PCC or PDC, what will happen? That oxygen and 2 hydrogen, can you see, will be removed out as a water molecule. Can you see? And what you'll get? You'll get nothing but a ketone with 3 carbon atom known as propanone or acetone. Student, shortcut for this reaction is, again same, you have got a secondary alcohol CHOH which will get converted to C double bond O, which is a ketone. So using this shortcut you can directly get the answers. Yes, student. Now there are 2 note points you should remember, student. The first one, primary alcohol always on oxidation gives aldehyde, and secondary alcohol always on oxidation gives ketone. The second note point, please student, remember, very important, tertiary alcohol cannot be used to prepare aldehyde and ketones.